Hello folks, and welcome back to another lesson. Today we're going to be talking about something we call the binomial theorem. So we're going to start by trying to expand x plus 3 to the 10th. Remember, when we have exponents, we can't just distribute these in. What that means is that to expand this, we have to write x plus 3 times itself 10 different times. So this expanded will look like x plus 3 times x plus 3. See, that's 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now this is a pain to write out. We don't want to have to always do this. So instead what we're going to do is we're going to look at these expanded forms, see if we can figure out any sort of method or any sort of rule that we're using to write these down by looking at the coefficients. So let's say we have two things here, a plus b, and we're raising this to the 0 power. Then what we know is the expanded form is going to be 1, or the coefficient is just going to be 1. The next one, if we have a plus b to the 1, it's going to be a plus b, or our coefficient is going to be 1 and 1. What about for 2? Well, when this is squared, we get 1a squared plus 2ab plus b squared. So the coefficients would be 1a squared, 2, and 1. Okay, what about 3? Let's go ahead and take a look. Our coefficients are 1, 3, 3, and 1. So how is each row related to the previous? Well, if we look, these interior terms seem to be just what we add together. So for example, 2 we get from adding 1 and 1 together. 3 we get from adding 1 and 2 and 1 together. And our outside numbers always appear to be 1. So let's see if that works for 4 as well. Our coefficients are 1, 4, 6, 4, and 1. Does this also hold true? Well, let's see. 1 plus 3 gives us 4, 3 plus 3 gives us 6, and 3 plus 1 gives us 4. Okay, let's try this for the fifth row here. For this, we'll have 1. We'll do 1 plus 4, or that'll be 5. We'll have 4 plus 6, or 10. We'll have 6 plus 4, or 10. 4 plus 1 is 5, and we have a 1 on the outside. Now this is what we call the Pascal's triangle. And the Pascal's triangle says that our first and last numbers are going to be 1. And the interior numbers we get from adding the previous terms together. So the other numbers they're the sum of the two numbers above it. So using that information, what would the next row be? Go ahead and try to figure out what the coefficients for that next row would be. Let's go ahead and take our triangle. We'll just take that last row so we can write it out here. 1, 5, 10, 10, 5, and 1. The next row would be 1. We'd have 6 from 1 and 5. We'd have 15. We'd have 20. And we'd have 15, 6, and 1. So now I'm going to give you the whole Pascal's triangle up to 10 rows. And here we go. Here you have all of your numbers filled in. Now this is a little confusing, but the very first row is actually row 0. Then we go to row 1, row 2, and so on, all the way down to row 10. Now, if you ever need to figure out which row you're looking at, you can also look to the second number. That will tell you which row we're in. Row 2 has 2 as the second number, row 3 has 3, row 10 has 10. Now, how do we use this to expand binomials? Well, what we're going to do, this is a plus b to the fifth. We're going to use row 5 of the Pascal's triangle. Those will be our coefficients. Our powers of a are going to decrease. They're going to start at the highest value. So they're going to start at the highest value, which is 5, and they're going to decrease one by one until we get to 0. Our powers of b, or our powers of the second one, are going to do the opposite. They're going to increase. So these are going to increase. We're going to start at 0 and work our way up to the highest number, which is going to be 5. So this is going to increase from 0 to 5. From 0 to 5. So let's go ahead and see what that means. So we're going to be using row 5, that's this row here, for our coefficients. The first one is going to be 1. And our powers of a start at 5, so we'll have a to the 5. Our powers of b start at 0, so this would be 1, a to the 5, b to the 0. Our next term is going to be plus, our next coefficient is 5. Now we're going to decrease our power of a by 1, so we're going to step down. The power of a decreases to 4, but our power of b increases by 1, so it's going to be a to the 4, b to the 1. After that, our next coefficient is 10, so that'll be 10. Our power of a decreases by 1, so it's a to the 3, and our power of b increases, so it's b squared. We're going to keep doing this. Our next coefficient is 10. Our power of a decreases, our power of b increases. Then we get 5. Our power of a decreases, our power of b increases. And our last term is 1. Again, our power of a decreases and our power of b increases. So your first term, your a term, steps down from your highest number, goes 5, 4, 3, 2, 1, 0, and b starts at 0 and goes all the way up to 5. Now let's rewrite this, making sure that we have no more zeros. We're going to simplify this all the way. So this first one is 1 times a to the 5, and anything raised to the 0 power is just 1. So our first term will be a to the 5. Our second term would be 5 times a to the 4, b to the 1s, or we'd rewrite that as 5a to the 4b. Our next term would be 10a cubed, b squared. The next term would be 10a squared, b cubed. Then we'd have 5a to the 1, which we just read as a, b to the 4th. And our last one, we have 1. Anything raised to the 0 power is 1, so this is just b to the 5th. So this is how we use Pascal's triangle. The reason we're allowed to do this is because of the binomial theorem. And all the binomial theorem says is that for every positive integer n, if you multiply, if you have two things added together, and then you raise it to that power, you can use Pascal's triangle to figure out the coefficients. You decrease your power of the first one, and you increase your power of the second. So binomial theorem, this looks really confusing. All it's saying is that we're okay to do this thing here. Use the row of the Pascal's triangle, decrease your powers of the first part, increase your powers of the second part. Now let's have you all go ahead and try this one, a plus b to the 7th. First of all, which row are we going to use for this? For this, we're going to use row 7 because our power is to the 7th. What are our coefficients for row 7? Let's go ahead and look those up. They're going to be 1, 7, 21, 35. All right, so let's go ahead and keep those in mind. We'll decrease our powers of A, so A will start at 7, B will go down all the way to, or start at 0, go all the way up to 7. So our first term would be 1. Actually, let's have you all go ahead and do this. What would our next step be? What would our expanded form be for A plus B to the 7th? Using row 7, that was 1, 7, 21, 35, 35, 21, 7, and 1. So the next step would be putting in our values using these as coefficients. So we would get 1. We start with A being raised to the highest power, to the 7. B starts at 0. Then we put in our next coefficient. We decrease our power of A by 1. We increase our power of B by 1. We're going to keep doing this. So we'll have 21, A to the 5th, B squared, plus 35, A to the 4th, B cubed. We'll have 35, A cubed, B to the 4th. We will have 21, A squared, B to the 5th. We will have 7, A to the 1, B to the 6th. And we will have 1, A to the 0, B to the 7th. Now let's go ahead and have you try to reduce this. What would this look like completely reduced? To completely reduce this, we're just going to remove multipliers of 1. Anything raised to the 0th power is just a 1. And we'll write anything raised to the power of 1 as just itself. So in the reduced form, this would be A to the 7th plus 7, A to the 6th, B, plus 21, A to the 5th, B squared, plus 35, A to the 4th, B cubed, plus 35, A cubed, B to the 4th, plus 21, A squared, B to the 5th, plus 7A, B to the 6th, plus B to the 7th. So that's the basic idea. Now we're going to try to do this using normal binomials. So instead of just having A and B, we're going to have actual variables and values to deal with. So we're going to start by expanding x plus 3 to the 5th. We're going to go back to our Pascal's triangle to find out what we're doing. We're using row 5 because that's the power of our degree. Now row 5 reads 1, 5, 10, 10, 5, 1. And now we're going to put this all together. So we start with our coefficient is 1. X is going to be A, so we're going to start with 5 powers of x, and then B is going to be 3. So we're going to start with 0 powers of 3, and then we're going to work our way down in x and up in powers of 3. So our next coefficient is 5. We'll get x raised to the 4th, and 3 will be raised to the 1st power. We will have 10. We'll get x cubed, and we will have 3 raised to the 2nd power. Then we'll have 10 times x squared times 3 to the 3rd power. We'll have 5 times x to the 1 times 3 to the 4th power plus 1 times x to the 0 times 3 to the 5th power. And at this point, we're going to need a calculator to simplify all of these powers of 3 and multiply them together with our coefficients. For this first one, we have 1, and 3 to the 0 is 1, so our coefficient is going to be 1. For this next one, we're going to have 5 times 3 to the 1, or 5 times 3, which will give us 15 as our final coefficient. Then we have to multiply 10 and 3 squared. 3 squared is going to be 9, and 9 times 10 is going to give us 90. For this next one, we're going to have to figure out what 3 cubed is. We'll throw that into our calculator. 3 cubed is 27, so this is going to be 10 times 27, or 270. This next one, we're going to have 5 times 3 to the 4th. So what is 3 to the 4th? That's 81 times 5. And this last one is going to be 3 to the 5th, or 243. Now that was confusing, but all we're doing is we're figuring out our powers of 3, and then we're multiplying them to our coefficients. That way we can just have numbers and we can have variables. For this first one, our coefficient is 1, so we'll just be left with x to the 5th. Then we'll have 5 times 3, so that'll be 15 x to the 4th. Then we'll have 10 times 3 squared, or 90, so that'll be 90 x cubed. Then we'll have 10 times 27, or 270. Then we're left with x squared. Our next one is going to be 5 times 81. Let's go ahead and throw that into our calculator. We see that this one will be 405. And how many x's are we left with? We're left with 1. So this is x to the 1 plus 3 to the 5th. We have 1 times 3 to the 5th, or 243. So this is our answer for expanding out x plus 3 to the 5th. Let's go ahead and do one more of these. We're going to do 3x minus 2 to the 4th power. So what are the values for Pascal's triangle for row 4? Well, that should be 1, 4, 6, 4, and 1. Now 3x is going to be a, so we're going to start with all of the powers and decrease. Negative 2, because we have the negative here this time, is going to be b. Our coefficient is 1. We'll have 3x, and that'll all be raised to the 5th power. So you have to be careful here. Make sure we're multiplying everything to the 5th, times negative 2 to the 0. We'll have 4 times 3x to the 4th times negative 2 to the 1. We'll get 6 times 3x to the 3rd. Excuse me, my powers of 3x are off. We start with our highest power. So instead of having 5, we start off with 3x to the 4. We go to 3x to the 3, then 3x to the 2. And this term is also going to be multiplied by negative 2 squared. Our next term is going to be, next coefficient is 4. We go down 1 power in 3x, so that's 3x to the 1. And we'll have negative 2 cubed. Then our final will be 1 times 3x to the 0 times negative 2 to the 4th. And at this point, it becomes a calculator exercise, but we have to be super careful here to make sure that we're keeping track of our negatives and that our 3's and our x's are getting raised. So let's go ahead and do that. We're going to multiply these, so 3 to the 4th is going to be 81. So 3 to the 4th, this is 81x to the 4th, and negative 2 to the 0 is just going to be 1. For this next one, we have 4 times 3 cubed is going to be 27 times x, and then we're also going to multiply this by negative 2 to the 1st power, so times negative 2. This next one, we're going to have 6. We'll have 3 squared, so that'll be 9x squared. Don't forget our powers of x. And we'll have negative 2 squared. So when you're putting this into your calculator, make sure you're putting parentheses around the negative 2. That gives you 6 times 9x squared times 4. Then this next one is going to be 4 times 3x times negative 2 cubed. Remember to put the negative 2 into parentheses before raising it to your power. That'll give us times negative 8. And our last one will be 1 times 3x to the 0 is going to be 1. And negative 2 to the 4th is going to be positive 16. So now all we have to do is we have to combine each of these. So we have 81x to the 4th times 1, or that would be 81x to the 4th. Then we have 4 times 27 times negative 2. So that's not going to be plus, because we're going to have 4 times 27 times negative 2 is going to give us minus 216. So that's minus 216 x cubed This next one is going to be 6 times 9 times 4. So 6 times 9 times 4 is going to give us plus, or a positive, 216, and we had an x squared there. Then we have 4 times 3 times negative 8. Put that into our calculator. We see that that's going to be minus 96x. And then our last term is going to be 1 times 16, or plus 16. So this is our answer. 81x to the fourth minus 216x cubed plus 216x squared minus 96x plus 16. Now let's go ahead and have you all try a couple. We're going to have you expand x plus 3 to the sixth. So which row should we be using for this? We'll be using row 6. And let's go ahead and figure out what the coefficients are for that. The coefficients for that, if you look to your Pascal's triangle, are 1, 6, 15, 20, 15, 6, and 1. So now go ahead and try to expand x plus 3 to the sixth and get it fully simplified. What is that value going to be? So for this one, we're going to start with our coefficient 1. X is going to be a, so we're going to start with 6 of those. We're going to work our way down. And 3 is going to be b, so we're going to start with none of those, and we're going to work our way up in the powers. Our next coefficient is going to be 6. We're going to multiply that by x, and we're stepping down 1 in x. So we're decreasing x to 5. We're increasing our powers of 3 to 1. Our next coefficient is 15. We're going to multiply x. We're decreasing by 1, so that's x to the fourth. That's 3 squared. Then we have 20. X cubed times 3 cubed. Then we'll have plus 15. That'll be x squared. We're decreasing in x. We're increasing in 3. Then we'll have 6. X to the 1 times 3 to the fifth. And then we will have 1 times x to the 0 times 3 to the sixth. And now we get out our calculators and see what each of these will equal. So this will be 1 times x to the sixth times 1. Our next term will be 6 times x to the fifth times 3. Then we'll have 15 times x to the fourth times 3 squared is 9. Then we'll have 20 x cubed, and then 3 cubed, we put that into our calculator, is 27. Then we'll have 15 times x squared times 3 to the fourth will be 81. Our next term is going to be 6 times x, and then we'll have 3 to the fifth, which is going to be 243. And our last term will be 1 times 1 times 3 to the sixth will be 729. So now we just combine these all together. We have 1 times x to the sixth times 1, so that's x to the sixth, plus 6 times 3 will give us 18, x to the fifth. We'll have 15 times 9. That'll give us 135, x to the fourth. We'll have 20 times 27. That is 540, x cubed. Our next term will be 15 times 81. So that is 1215, x squared. Our next one is going to be 6 times 243. So that's going to be 1450. I'm going to write that down here, plus 1450x. And then we have 1 times 729. So that's plus 729. So that's our answer right here. Now let's go ahead and do problem 2. Problem 2, which row are we going to be using? That's row 5. Now I'm not going to give you the coefficients for this, so go ahead and look back at your Pascal's triangle or find it online, figure out what the 5th row coefficients are. And let's figure out what this is completely simplified. Now our coefficients for row 5 are 1, 5, 10, 10, 5, and 1. When we write this out, we'll get our coefficient is 1. Our a term is 2 to the x, so that'll be raised to the 5th power and will be decreasing. And negative 1 will be raised to the 0th power and will be increasing. Our next term will be 5 times 2x to the 4th times negative 1 to the 1. Our next term is going to be 10. We'll have 2x, and all of this quantity is cubed, so I wrote it wrong. And this last one should be 2x, and that quantity is raised to the 4th. Then we'll have negative 1 squared. Our next term will be 10. We'll have 2x, and that quantity will be squared times negative 1 cubed. We'll have 5 times 2x to the 1st power times negative 1 to the 4th. And then we'll have 1 times 2x to the 0 times negative 1 to the 5th. Right. Let's go ahead and simplify these. So this will be 1 times 2 to the 5th, which will be 32 x to the 5th times 1. Negative 1 to the 0 is just going to be 1. Then we'll have 5 times 2 to the 4th will be 16 x to the 4th. Then we'll have times negative 1. Then we'll have 10 times 2 cubed is going to be 8 times x cubed. And negative 1 squared, negative 1 times negative 1 is positive 1. We'll have 10 times 2 squared is 4, so 4x squared. We have negative 1 cubed, so that'll be back to negative 1. Remember, go ahead and throw that into your calculator. Make sure you put the negative 1 in parentheses. Our next term will be 5 times 2 times x, and negative 1 to the 4th should come out to be a positive 1. Then our last term will have 1 times 1, and negative 1 to the 5th should be negative 1. So when we go ahead and combine these, our answer should be 32 x to the 5th, and then we'll have not plus, because we have a negative 1. This should be minus 5 times 16, where that is 80 x to the 4th. Then we'll have 10 times 8, so that'll be plus 80 x cubed. Then we have minus 10 times 4, or 40 x squared, plus 5 times 2 times 1 is going to be 10x. Then we have 1 times 1 times negative 1, so our answer is minus 1. The full answer, 32 x to the 5th minus 80x to the 4th plus 80x cubed minus 40x squared plus 10x minus 1. And that, folks, is all we have for this lesson on the binomial theorem.